Okay, so welcome everybody to episode 14 of the SFU Sports Analytics Group virtual seminar series. Today, I'm pleased to present Dr. Johann Windt from the Vancouver Whitecaps FC. He's going to speak to us today about injury prevention, workloads, and analytics, research, and applied practice. Dr. Windt is the head of data science performance with the Vancouver Whitecaps FC of Major League Soccer. His primary objective within this role is to make everyone else's jobs more effective and efficient by overseeing data collection, integration, and reporting across football operations, including scouting and recruitment, sports science and medicine, player development, and first team football. Prior to joining the Whitecaps, Dr. Windt worked at the United States Olympic and Paralympic Committee as a sports medicine data analyst, where he helped to build their athlete 360 monitoring program. This program was responsible for athlete workload and self-reported wellness monitoring of more than 400 athletes representing more than a dozen sporting disciplines. An important component of both of these roles was collecting, modeling, and communicating workload and injury data, a task largely informed by his doctoral work at the University of British Columbia, co-supervised by professors Karim Khan and Tim Gavitt. His dissertation was entitled Longitudinal Workload Monitoring to Keep Athletes Healthy and Performing, Conceptual, Methodological, and Applied Considerations in Sport Injury Etiology. Today, his research and professional interests include how technology and data science can inform organizational decision-making, both in the daily training environment and through longer-term research and innovation. So today, the topic of his talk, more specifically, is that he will speak broadly about injury prevention and workload monitoring, and how the analytics community can best serve both the academic and applied environments in regards to these topics. By overviewing the academic frameworks for injury etiology and injury prevention research, he hopes to highlight how the analytics community can solve a primary problem in the academic research, in which well-developed theory and continually richer data sets have been analyzed with suboptimal statistical approaches. On the applied side, he will showcase an example of how a data science team can engage with workload-related technology to inform decision-making within an organization pertaining to injury prevention, as well as a range of other issues across departments. And so with that, I'm going to stop sharing my screen and hand it over to Dr. Windt, and we look very much forward to your talk.
All right, Dave, if you don't mind giving me the green light, do you see the big full screen presentation or the presenter view side?
Nope, big screen, and you look like you're all set to go.
All right, perfect. Thank you in advance, everyone, for your time today. It's really a pleasure to come and get the opportunity to speak. Dave, thank you very much for the invitation. By way of a brief, my slide will change for me. A couple quick disclaimers, no conflicts of interest related to this talk at all. My background is more of a sport and exercise scientist by background than data scientist statistician, though my career trajectory has kind of taken me in that direction, but it's a useful point to make. Currently, as my bio highlighted, I'm in a professional sporting role where only probably about 5% of my actual job today is around workload and injury directly, and we'll kind of speak about how that looks at the close of the talk. And then also, I think it's worth mentioning that usually I'm giving talks and addressing a sports science and medicine community more around how to use data effectively, and this talk is more geared towards, I think, an analytics community and analytics audience. So I'm going to be overviewing some sports science, sports medicine frameworks that might be assumed knowledge in other audiences, and then get to specifically how can the analytics community best serve both the research and applied environments in this perspective. So by way of overarching outline, first we'll touch on why we should care about injury prevention as a sports analytics community at all. If there's not really a strong rationale for doing so, then you can ignore the rest of the talk. But if you agree that there's some justification there, then we'll carry through. Like I said, we'll overarch and talk about the overarching theory around both injury prevention and then athlete workloads and those associations with injury. And then I want to conclude on those two questions of how can the analytics community first serve injury prevention research. And I'll just lead with kind of my thesis statement so you know where this talk is going to get to at the end. We'll take this journey through those frameworks and land back here. So from an academic perspective, I think the analytics community can collaborate with sports medicine, sports science researchers to understand the underlying theoretical frameworks and then apply modeling approaches that more accurately represent and explore those frameworks. It can also introduce more robust modeling approaches. Yeah.
Sorry to interrupt. You're just a bit echoey. I don't know if there's anything you can do on your end to fix it, but just an FYI.
Okay. If I move further away, I just moved my laptop a bit. If I back up, is that better?
Yeah, it is. It is. We'll see it. I think it shows your signal is pretty strong. I'm just not sure. Yeah, if it's a microphone conflict or anything. But anyway, it's audible. I just wanted to see if we could maybe fix it up a bit. So let's give this a shot.
All right. So I tried the laptop move. If it keeps being a problem, please don't hesitate to interrupt. I can try and move around.
Okay, great. Thanks.
Yeah, I think secondly, the other piece that the analytics community can do is to introduce more robust modeling approaches that also make use of the workload and injury data sets that we're now able to access as kind of technology improves. On the applied side, where I'll get to is I think the analytics community can critically evaluate and validate new workload and screening related technology before they're integrated into practice. They can integrate those data sets with other data streams that are already available or going to be available in the organization. And by establishing strong relationships with other practitioners, they can understand the key questions that are facing those colleagues on a day-to-day basis. And workload and screening data might help to inform several of these decisions. And we'll get to that again at the end. But let's start with why this topic's really relevant at all. And I think a helpful starting point for me is even just looking at this sequence of analytics seminars, and so many of them focus on an aspect of sport performance. So a recent one was on should we be crossing the ball in football? There's a draft and scouting and recruitment optimization frameworks. There's a lot of these performance-based models. And essentially we understand in team sports, as an example, the talent that you're able to put on the field is largely going to be related to your success as a team. However, if you have the best scouting and recruitment modeling approach and you pull in the most talented 11 players possible to play on the football pitch and half of them are injured going into a game, all of the modeling and all of the effort from a performance perspective is going to be largely hampered because they're unable to actually perform. And if you look at the body of research around how injuries affect both team and individual sport performance, it's pretty clear. If you have a team and more players are unavailable, the performance of that team is going to go down. If you're an individual athlete that sustains injuries and misses more training sessions, you're far less likely to reach your performance goals. And as well, there's obviously also the financial ramifications where if a team and an organization invests millions of dollars in an athlete to come and play and they're unavailable, it's equivalent to losing hundreds of thousands of dollars with each missed match opportunity. So I think understanding what we know about preventing these injuries from occurring is an incredibly important consideration when the sports analytics community as a whole is focused on optimizing performance in whatever way we can using a statistical and mathematical approach to these problems. So that's the why. Hopefully you agree that there's enough underlying gumption to keep going. So we'll start with a broad overarching, can we even prevent these injuries from occurring, or are they just a completely inevitable part of sport? So if you went to a sports injury prevention conference, I can almost promise you that one, if not half of the speakers would have this slide. So this is a model put forward by Professor Willem van Mechelen in 1992. It's a sequence of prevention where you establish the extent of the problem, you understand why the injury occurs, you introduce a preventative measure, and then you assess whether the preventative measure was actually effective by seeing if there's a change in injuries. So we can unpack each of these, starting here at understanding the extent of the problem. I won't spend a ton of time here. I think Dr. Richards did a great job in a previous talk, if you haven't seen, at unpacking some of the issues in knowing. He said he's going to focus on the numerator, that being injuries. So to briefly touch on a couple of those pieces, injuries per 1,000 hours, how we define injury actually has a pretty broad range of how we can go about doing that. So in this editorial, they say what constitutes a recordable event is arguably the most critical methodological factor affecting the results of sports injury and illness surveillance studies. Although numerous consensus statements have attempted to standardize surveillance methodology, there remains considerable variation in current definitions of injury. So one of the consensus statements, for example, that they refer to in this is Colin Fuller and colleagues' consensus statement. This was specifically around soccer injuries, but even within this consensus statement, you could define an injury using an all complaints whenever something comes up. You could use medical attention. Do they see a medical practitioner? Do they miss time as kind of the time loss injuries? And then you could even say match time loss injuries as a smaller subset. So if you choose to say how many injuries occur per 1,000 hours in this football team, obviously there's far fewer time loss injuries than medical attention injuries. And even beyond this, there's this challenge where time loss injuries are often biased in sports injury research because they're easier to quantify, because you say, okay, they missed a training session, they missed a match. So often that's used in the literature, but then again, Dr. Richards talked about this a little bit, but the Oslo Sports Trauma Research Overuse Injury Questionnaire was developed in response to some of the limitations in sports like volleyball. So you might have athletes that have very, very consistent shoulder pain, knee pain, back pain, and they're in pain an entire season, but they never miss a training session or a match because it's just considered part of the sport. But clearly, if their performance is hampered, there's an argument to be made that this should be considered a sport injury. And in this instance, they did a standard method of kind of injury definition where they identified 40 time loss injuries, but 379 injuries if you use the OSTRC. So all of this is just to say that just establishing the extent of the injury problem, even defining what an injury is, poses the first challenge here. But let's say we carry that forward and we say, okay, we're going to use time loss injuries or whatever definition consensus is there. It's also not the same if you have 10 ankle sprains or if you have 10 ACL ruptures. There's this concept that we need to take into account how severe these injuries are. You might look at days lost per injury, and you could look at the total of these things through injury burden. So some have proposed now, let's look at injury burden rather than severity or incidence in isolation. So in the editorial where they discuss this here, this is injury data based on the UEFA Football Research Group data set, one of the largest sports injury data sets in sports. And you can see hamstring muscle injuries pose the largest burden in professional football. So they have an incidence up at the level of lower leg contusion. So obviously football, soccer players get a lot of bruises on their lower legs from tackles, etc. They also experience a ton of hamstring strain injuries, which are, as you notice on the y-axis, they're more severe than obviously having a bruise on your shin. So from a burden perspective, if you wanted just to tackle one injury in football, hamstring strains would be the way to go. So we'll carry this example forward to illustrate what this looks like. If you take the broad estimates, you would say if you had a team of 20 football athletes, you'd assume 4 hamstring strains are going to occur throughout the course of the season. So that, for this example, would be the extent of the problem. We're probably going to see 4 players go down with hammy strains. The next step in the model would be establish the etiology, the mechanisms of injury. And then if you went to that sports medicine conference I'm talking about, you would see that sequence of prevention model. I can almost promise you would see some iteration of this model by Dr. Mayvisa put forward in 1994 saying, look, injury is not a really simple, if this happens, then an athlete gets hurt or not. It's a multifactorial construct where you have intrinsic factors that predispose an athlete to injury. The examples in this case being age, flexibility, previous injury. You have some exposure to external factors that make them susceptible to injury. And in cases of injury, there's some inciting event, that being a tackle or a muscle strain in our example. And trying to understand which of these factors are associated with a higher risk of injury helps us to understand what we might be able to do to intervene. So in a hamstring strain example, a couple of the factors that people have identified and looked at as correlates to hamstring strain injury are fascicle length. You look at the length of the muscle fascicles through ultrasound, and eccentric strength of the hamstrings. This is led by a group in Australia in Tony Shields' lab. Ryan Tim has done a lot of this work, but this is just one example here where they say, look, there's this bottom left corner, they call it the quadrant of doom, where players that are measured with weaker hamstrings and with shorter fascicles seem to get injured more frequently than the group up on that top right. there's limitations here and we can talk about them, but let's take this at face value and say, it seems like weak hamstrings with short fascicles is not great for hamstring strains. You can update this little model and you say, look, let's throw in athlete predisposition seems to be impacted by eccentric strength and fascial length. So we've learned something about the etiology of the injury. We want to introduce a preventative measure. So the question would be, do we have an intervention that changes that risk factor? Age was an example of one of those predisposing factors that might be considered, but we can't really change it. What we want is something that we can intervene and modify. And here you can see an example, a picture of a Nordic eccentric hamstring curl. So it's essentially a slow curl. Doing this exercise, you can see on the right, you can see the bubbles move from those big bubbles up and to the right. So these are 4 different studies. 3 of those use this Nordic exercise. And you can see that consistently participants moved up and to the right, away from that kind of quadrant of doom that they call it, into a more, at least theoretically, lower risk state. So we know that you can actually change those predisposing factors. However, that doesn't actually tell you that you prevented the injury, just that the predisposing potential risk factor was changed. So then what you want to do is go to something like a randomized control trial where you can say, are we actually seeing fewer injuries? And this is one example. The Nordic was the intervention in this randomized control trial. You had almost 500 or over 500 players in total, 20 teams allocated to each side, and you essentially see more than 50% reductions. You see less than half. So in theory, if we carry this example through, if you did the Nordic as your preventative measure, maybe you see not 4 hamstring strains, but 2. And obviously, if those 2 players are some of your more valuable, talented players that you identified through your really successful scouting and recruitment model, that has a pretty dramatic effect on team performance. So that would be the overarching framework for injury prevention. You'd see presented and discussed in a lot of these conferences, and provides helpful background information as we continue forward. But what we didn't talk about at all is athlete workload in any of that example. And one of the reasons why was in the earlier models of injury etiology, workload wasn't really considered explicitly within the model. There was a lot of these factors, and these factors were often looked at in screening protocols, often at the beginning of season. So you measure something in preseason, then you follow the athlete over the season and see if they get hurt. So that hamstring strain, for example, how weak or strong are their hamstrings when they come to camp? And then who got a hamstring strain during the season? Often not knowing if they actually got stronger before they got injured, or knowing anything about their training leading up into the injury other than kind of exposure hours. This 1994 model was then updated and talked about more in 2003, 2005 by Professor Roald Barr and some colleagues as well. And then in 2007, Dr. Muvisa again proposed now a dynamic recursive model. I think this, at least in these sequence of models, is the first time workload entered in an explicit way. You have this upper right-hand corner. So now it's not this inciting event and linear path, but athletes often engage in sport in inactivity and they don't get injured, in which case they will return back and participate again. And there's this kind of question and acknowledgement in this model that they're not actually going to go back and train again with the same risk profile. There might be some adaptation from training itself. So again, for those of you that are in a sports science background, you'll be very accustomed to the idea of workload, but I'm going to take a quick tangent. When we talk about workload, what are we really referring to? So in this case, let's just say this is runner Bob going for the Vancouver Sun Run. It'll be post-COVID, so you can run with groups of 10,000 people again. When we think about workload, we could ask the questions of, okay, runner Bob ran 10 kilometers. It's the Sun Run, it's 10 kilometers. But if you define it that way, then it's just a distance covered, and it's not the same. It's the same thing whether he runs it in 30 minutes or if he runs it in 65 minutes. So you could maybe look at distance and time run, but then obviously the fitness level of Bob will determine his physiological response. So a elite marathon runner running 40 minutes is really easy compared to a recreational or non-runner doing it in 60, for example. So maybe you would look at what's the heart rate response of the runner throughout the course of the sun run, or how hard did they perceive training to be. All of these kind of have been captured in the physiological literature through external training load being the distance or the amount of work that the athlete is doing. And based on their individual characteristics, their fitness level, their strength levels, et cetera, that'll determine how they respond to that load. And then that internal training load kind of dictates your positive training and your negative fatiguing adaptations, and you get your training outcome. This kind of underlies training periodization. And again, for a more in-depth talk, Dr. Clark would be more well-versed than I to talk about all of the different mathematical modeling approaches with some really helpful papers in this area. But the basic principle is you have the workload, you apply some training stimulus. For a period of time, there's some fatigue, but the athlete recovers, supercompensates, and is prepared for a better performance down the line. So you have this idea that performance for the athlete is the fitness they've accumulated minus their current level of fatigue. You kind of have these two impulses: smaller training impulse, smaller responses; larger training impulse, larger responses, all other things considered. Now, this is done in a performance realm. You can use this general principle to predict endurance performance, for example. The other question is, at an underlying theoretical level, how an athlete trains and how they progress that training may also predispose them to be more or less likely to actually get injured. There's a body of literature that's grown, especially in the last 10, 15 years, and they've looked at this question, kind of this: how do total athlete loads over a given time relate to injury risk? Does load progression predispose them to risk? And how do we interrelate load and load capacity? So for the sake of time, I'll skip over, obviously have to skip over large chunks of this literature and just highlight probably the most frequently used measure of load progression for the sake of our discussion today. We'll get into some of the limitations, but for those familiar with the field, you'll know of acute chronic workload ratio as a metric of load progression. For those of you who don't know, if this is the current day, your acute load would be these last 7 days of training, your last week. Your chronic load will be the last 4 weeks of training, and you can relate what's this last week to the last 4 weeks. This is traditionally just done as a simple ratio. And then you might look at an athlete's predisposition to injury in the following week or 2 weeks or a given time period, and you essentially are able to follow this athlete as they train. Again, for those familiar, this isn't revolutionary. This is just 2 examples. So if you have that being your acute week, maybe these are runner bobs, 8 weeks leading to the sun run. Most recent would be acute, last 4 will be chronic, and that would look to be 0.9. So we would call that reasonably stable. And on this second example, we have an athlete that's training and ramping up pretty drastically, where the most recent week of training is substantially more than the weeks before. This is what a 1.5, which some people would say, look, this is an area of concern. This is what it looks like if you just graph that out for 8 weeks. And again, only those most recent 4 weeks are taken into account in any way in this calculation. If you looked at this literature as it kind of picked up, especially in the last 7, 8 years, the messaging and the consistent discussion was, look, we don't want to do too much too soon. When you progress training too fast, you're at a higher risk for injury. Enough papers were actually published in this realm for a couple systematic reviews to be put forward and also support this notion that, look, more training done too quickly might predispose athletes to get hurt in a subsequent time window. So we're not going to dive into the results of these reviews necessarily or the individual studies, but enough to say, for those of you unfamiliar, this body of research accumulated pretty quickly. And at the same time, the etiology models that I talked about didn't have an explicit way of incorporating how workloads related to injury risk at all. So as part of my doctoral work, we put forward this kind of workload etiology model where workload is applied and you have the same basic principles where training will induce positive physiological changes. By training and having workload applied, you might get a stronger, fitter athlete that's more robust, but also if you do too much too soon in the realm of kind of what those papers were presenting, you might be at risk of essentially inducing some negative adaptations, not allowing the tissue or the body to recover and predispose an athlete to injury risk. Now, it's a nice story to carry that through. And if we ended there, it would be, I guess, a neat cap on that. But it's really important to note, largely from a methodological and I guess analytics community, there's been a bit of a pendulum swing away from this narrative of load progression, especially through a simple acute chronic workload ratio. And people have raised several concerns. So some of these are more mathematical, just in terms of how the ratio scales. So there's a mathematical coupling. The acute load is taken into account both in the acute, your most recent week, and in the chronic. And there's some inherent problems with using ratios as metrics that apply here as well. As part of my PhD, we also looked at the methods and the statistical approaches that people have used to look at workload and injury. And some of those haven't been optimal. And there's some more overarching challenges that people have raised and said maybe acute chronic workload ratio needs to be revisited or displaced with another approach. So I think the logical question is, where would we want to go if we were to move away from or forward from the acute chronic workload ratio, and what are the theoretical frameworks that might guide that? So I'll briefly touch on a few of those. One is this idea, let's move away from risk factor identification and a more linear assumed factor 1, 2, and 3, and more look at a web of potential determinants of injuries, and what are these profiles when different risk factors come together in this web to produce some emergent pattern, in this case injury. But let's adopt and learn from complex systems approaches. We've also seen more tissue-specific models presented. And I think this is a really important point, that a rolling average of 1 week to 4 weeks of training is reasonably arbitrary in the sense it does capture progression over a given period of time. But we also know physiologically that bone turns over at a different rate than ligament, which turns over at a different rate than tendon. So if you wanted to injure those tissues by loading them in the worst possible way, it probably wouldn't be just a 1 week to a 4 week ratio. It would be a work sequence that damages the tissue and doesn't allow for recovery. In the same way, building those tissues up, you would do those differently. So this is an example of a running specific framework put forward by the Run Safe group in Denmark, where they look at essentially just load on tissues with every stride and the number of strides taken, which is a more tissue specific model. And in alignment with this kind of tissue centric approach, there's also the call for more causal framework approaches. I'm thankfully going to have Dr. Schreier's talk to listen in on in a couple of weeks when he presents here, and I know he'll be unpacking this more. But taking into account both, I guess, screening related, tissue related factors and load related factors to understand how these interplay to create a potential risk for injury. In terms of where these frameworks stand, this is probably the most recent one, and the starting point if you're interested in reading more and learning more. Dr. Franco Impellizzeri is one of the people that would probably displace the acute chronic workload ratio altogether, and this is the framework that they have put forward to think about injury etiology and how workload plays a role. And it borrows from and has insight both into the tissue specific context as well as the load progression. And again, I can't recommend enough. Dr. Schreier is going to come and talk. They've also published a really nice paper that looks at the lessons we've learned in the acute chronic workload ratio realm, and also calls for more causal inference approaches to understand the load injury relationship a bit more in depth. So again, I won't speak to this at great length here, but just recommend you listen to his talk, and if you're interested, to jump in and read this paper as well. So with all of that said and the underlying frameworks presented, how can the analytics community kind of come to this party and most benefit it? I think a helpful point for me when I think about this is actually going to a paper that wasn't in Sport at all, but Linda Collins in the Psychology Journal, she published this in 2006, talked about longitudinal data analysis being an integration of your theoretical model, temporal design, and statistical model. So in this case, what is the theory that we understand to be at play? So in workload and injury, these are some examples of those theories. The theoretical framework informs the temporal design, or just your data collection approach. How frequently do you collect data, and what data are you collecting? And then finally, you want a statistical model that aligns with both of those things, takes advantage of the fact that you have data collected with a frequency that makes sense, and answers the actual questions you're getting to or questions you're asking from that framework. As part of my PhD work, one of the questions that we had was, have groups that have looked at the workload injury relationship done this effectively? So we have different challenges that are posed by the theoretical models, that injury is multifactorial, that there's differences in risk between and within athletes. We have recommendations to take a complex systems approach to injury etiology. And then intensive longitudinal data presents challenges as one example of a bunch of observations nested within one athlete, because the one athlete engages in training sessions and matches over time. What approaches have been used by researchers to analyze this question, and do they address these challenges pretty well? And essentially, the most frequently used statistical approaches didn't address many of these challenges. So the most frequent approach that researchers had used was just a simple regression model that doesn't take into account the clustered nature of the data, so that the assumption of independence is violated. Or you saw examples of an entire season or preseason worth of data collapsed and running something like a simple correlation or a t-test. So you have a lot of the challenges posed by both the theory and by the data set at hand, and the approach tried to get at the questions we want to know, but probably in a suboptimal way. So I think I'm going to skip over this next slide here just to say, this is, I think, where the analytics community can really, I guess, benefit the research realm. I think we have the theory that's pretty well developed. We have data sets that are now continuing to become more rich as more technology allows us to get access to these data sets. And we have used the models that make the most sense and kind of get to where we really need to or want to get to. So I think we're growing and we're learning. So one of the approaches that has been recommended is more robust time to event modeling, which just presents one additional challenge. So this is again by that RunSafe group in Denmark, and Rasmus Nielsen puts forward this modeling approach. But you can see in this example, you actually need 1,800 injuries required if you wanted to have 3 different groups and states of load transition. And in our single team football example, we only had, in theory, 4 injuries in a season. So if you wanted that data set from a single team, you would need to monitor them for a couple centuries to get the data set to run this model. So there's also a call in the research realm: can we establish more international collaboration and build data sets that allow us to actually have the power to answer these questions and to run these statistical approaches that we acknowledge are necessary and welcome, but require a level of data that you're not going to see in single team studies. And again, that paper by Dr. Schreier talks about how a lot of the acute chronic workload ratio work has been done in a very underpowered sample. So to kind of recap, I did say this is where I'd land on the research realm before we kind of cap off on the applied side. I think the analytics community can help inform injury prevention etiology research by collaborating with the sports medicine, sports science community to understand the theoretical frameworks and then apply modeling approaches that more accurately represent these frameworks at play. And then also introduce more robust modeling approaches that, as the data sets continue to get richer from a workload and screening perspective, apply approaches that make sense. And again, Dr. Schreier, I think, is going to unpack some of that more from a causal inference perspective as well. I want to conclude on the applied side. How can the analytics community inform applied practice around workload monitoring and injury prevention? Now, I think at the very start, I made the disclaimer that my work is now only 5% workload injury related. And the reason is, when I work at the Vancouver Whitecaps, my job isn't to answer, do workloads relate to injury risk, and how can we look at that from a causal inference perspective. My job in my work is to try and help practitioners make strategic performance-related decisions and just try and help inform the decisions that they're having to make on a day-to-day and longer-term basis. So these might be scouting and recruitment decisions, they might be tactical decisions, they might be player development and academy decisions. We have really, really intelligent, brilliant people in these roles, and they make these decisions on a day-to-day basis. And all I'm trying to do is take advantage of the information we have at our disposal and provide them with the data in a way that makes sense, that can hopefully just add one more piece to the puzzle that they're building. Workload and injury is just one small component of this, and probably within that sports science realm. So these are relationships that I would have and have with our physical preparation staff, with our therapy staff, to say, how can workload or screening data make your job and your life easier? I think it's worth mentioning as well, Stephen West captured this really well in this recent paper, that workload data doesn't just answer a injury question, whether someone's more or less likely to get injured. It actually could answer a whole host of performance-related questions that are all really relevant depending on the practitioner in their sporting environment. So the example that I'm going to provide to walk through this in the Whitecaps perspective is we looked at using player maker devices. So essentially they're foot-worn accelerometers. You can see those on the boot here. And theoretically, if I were to ask our physical preparation staff, our therapy staff, would this help you make decisions? The type of things that we can get to is to better understand and quantify match demands for our academy athletes. It would allow us to compare planned and actual training loads during training sessions. It would allow us to monitor and show longitudinal performance improvement in certain activities. If we did maximum velocity runs on a given frequency, having this technology in place helps us to track and look at player performance changes over time. And if an academy player is injured, it gives another piece of the puzzle to help guide return to play decisions as they get back into training. As you can see, these are all examples of questions that we might answer that actually aren't who is at risk of getting injured, but they're really helpful and important pieces that we can answer using workload related technology. I think where the analytics community comes to play is not necessarily in answering the question of would the promised information be helpful, which I think is a question that you ask the practitioners you're working with. Would having access to this workload data help your job and your life be easier? We put a framework together, myself, Dr. Kerry McDonald, and others, on how do we evaluate whether or not we adopt a given technology. And I think the analytics community doesn't necessarily thrive in that first one where the subject matter experts answer, but if the promised information would be helpful, I think it's really pertinent for us as a quantitative community to say, can we trust the information we're getting, and can we integrate and manage, analyze that data effectively, and then return back to the group to answer the question of, can we implement this? So it's nice to put forward a theoretical framework, but we work through this in real life with the player maker devices. So first, myself, and then these images also include data from Alexander Hinton and Quinn Thompson, two other members of our data science team, where we would wear catapult pods, we would wear player maker devices. We went out for several sessions. Last year, we had a trial from the company to just try and understand this question. Can we trust the information we're going to be getting? We know that having workload data at the academy would benefit us as a club, but we also didn't have any external peer-reviewed literature from player maker at this point to say, okay, these foot-worn accelerometers provide really accurate, reliable measures of total distance or high-speed running, or the different promised outputs. So we wanted to look at that for ourselves to know, what are we going to get? And then secondly, we don't just want to have another source system where people have to go to another web page or log into something else. What we want to do is pull the data out of the system, push it into our own internal database to try and understand how academy loads relate to all of the other things that we understand about these athletes, their coach evaluations, their wellness on a day-to-day basis, their screening, strength, fitness related data. So as part of the trial, one of the pieces that we're also doing is, can we download the data? Can we clean it and integrate it into our system and within our database? Because if we're unable to do that, the ability to answer some of those questions that we talked about early on is also hampered. So I think for us, these were the two questions, at least on the player maker example, that are really, really important for the analytics community to come on board with. So if something comes up that practitioners really want and think would be helpful and feel they can implement it, we can really speak to those middle 2 points. So we can critically evaluate, validate new workload screening technologies before we integrate them into practice. We can work to to integrate that data stream from the technology with everything else that an organization has, the technical, tactical data, the subjective coach evaluation data, all of the other pieces at our disposal, as well as the injury piece. And through strong relationships with other practitioners, we can understand the challenges that they're facing, the key questions that they need to answer, and where workload, screening, injury-related data would be helpful, we can analyze and provide that information in a way that helps them make the decisions that they need to on a day-to-day basis. So I think that applied one is very different than how the analytics community speaks in an academic realm, where the task is much more concrete, workload straight to injury. In an applied environment, the same piece of data, like workloads progressed over time, can speak to many, many different practitioners and answer a variety of questions. So yeah, with that, I think I'm definitely a few minutes over, but thank you very much for your time. I'm excited to take some questions and unpack this further, and thanks again for the opportunity.
Awesome. Thanks very much, Johann, for that talk. So we'll turn on my video here and switch the screen. Okay, so we will take questions. So again, if we could start, if you have questions, post them in the chat box. We didn't have any questions during the talk. So I will maybe start with one. So, I guess one of the major things here is, like, you've got that time to event modeling as one suggested way to, in terms of appropriate analytics for handling these types of data. Like, what about sort of these sort of causal graphs and Bayesian approaches? And again, I might be speaking beyond my expertise here, but I'm kind of thinking of, like, for example, the athlete biological passport. Like, that's, for me, is another quintessential example of the marriage of theory with the data, and for a very robust application in sport. What are the other alternatives, I guess, that have been considered in your field?
Yeah, I think I'm thankful again that I did put on slide number 2 that I came more out of sport and exercise science than straight through statistics. So I will immediately defer a little bit to Dr. Schreier, who will come, that I know will speak far more intelligently. I think he's on the call here around some of these causal approaches, because the questions we're facing on workload and injury theory, they are causal questions. We want to know, does the way that athletes are training cause an injury down the line, right? So they're, at a theoretical framework level, they're causal related questions that people have used methods essentially of just group-based differences to answer. So in the paper where we looked at which models address more of the challenges, there were time to event. The frailty model is one example. A multi-level model that I've used in the past at least takes into account the clustering of data within athletes and allows us to look at some of the between and within athlete differences in risk, but it still probably isn't optimal. I think there will be people more intelligent than I to speak about what I think optimally we would do. So I'd be tempted to throw ideas out, but I think there probably have some people who would call me out on my limit, so I'd cap it.
All right, fair enough. Tapping out. Well, if there's anyone in the audience, if they have some ideas, I mean, I think this is kind of the crux of the discussion. So if anyone jumps in particular, Dr. Schreier, your name's been mentioned a few times, and we don't want to steal the thunder of your talk coming up, of course, but if you have any comments to add, or maybe others in terms of ideas, now would be a great time.
Okay, so it's Ian here. A lot of what's being talked about, this causal things and the workload, and that's separate. I think maybe just to, and the Bayesian approach, these are all nuances and can get very complicated. But you mentioned the biological passport, and I think that's an interesting question. And so I'd like to comment on that specifically. The biological passport is not a causal analysis. It's a predictive analysis. So what they're looking for are patterns that predict something that looks unusual. Now, it's not just a predictive analysis, it's actually an outlier analysis. So it's looking for normal variations, and then what you say is all of a sudden you get a result that is outside what you would normally consider as normal variance. And that's what the biological passport is about. So it's a predictive analysis, which is really an outlier analysis. And because they have a lot of data, over thousands of people, they know what normal variations are. And if you exceed that variation, something is different. They're interpreting it as doping. Sometimes it might be something else, which they understand. You might become severely dehydrated and your concentration can go way up. But that's what that analysis is. And it's very important. A lot of the papers that Johann was citing, they don't define their question. And so there is no one analysis that is the right analysis. And the more, like he showed, that one with the running, and you'd need to record people for 50 years, obviously is not the right analysis for us because we don't have enough data. So we always return to the question, and whether or not you should use rates, time to event, depends on your question. And so we always, I mean, it's just basic science. None of this, also, all of those models he showed all come from standard epidemiology for which sports scientists have read other things and just adapted them. None of that stuff is new. It's all very worked out in terms of the ideas. And I'll touch on some of that. My talk, just because Doug was talking about it before, and Johann, my talk's going to be much more of a merging of mediation analysis, which is a little bit what Johann, mediation and interaction, but also much more about what machine learning can do there and what it can't do, because I know you guys are doing a lot of machine learning. And the big problem for us in causal inference is overinterpretation of the data. And Johann was very, very careful about what you can get out of the different types of data you get. So mine will give you some specific examples as well.
Excellent, thanks. Does anyone else want to chime in on the question? I guess, yeah, what is the question, I guess, is the first thing to figure out for, and that will depend on everybody's specific context. So perhaps maybe we'll hold off on that, trying to answer that particular question. Okay, so there's a question in the chat from Carrie McDonald. Do you use the acute chronic workload ratio within the Whitecaps? Is it a valued metric by your IST or coaching staff? Why or why not?
It's a great question. It's on the record here. We show a lot of things within different athlete monitoring dashboards, and the acute chronic workload ratio is included as a host of metrics that is visible, not for a, let's say this athlete is at given percentage of getting hurt, but we do view the both acute load and chronic load in regard, because we've come to learn what we would expect at different periods of the season. We know that we are going to build athletes when we have, let's say, a bye week. So we know we can focus heavier, we can load them more. We know during times of preseason what we would expect on a weekly basis. And when our athletes are fit and performing well, and we feel like they are feeling really good, that actually does correspond pretty well with the chronic levels that we have seen for the last 4 or 5 seasons looking at these acute and chronic loads. I'd say, though, I think the acute and chronic loads in separation probably provide us as much or even more than the ratio itself. We just understand what that means week to week, and we understand where we want athletes to be. And those both are valuable when you are returning a player as well, or especially players that aren't involved on the weekend as much. We want to make sure that they're still training at the level of our first team athletes. So the acute chronic workload ratio is there. We see it. We know that there's a lot of limitations with it, like what I mentioned, but it's another component that we take into the decision-making process. And the acute and chronic in isolation do carry a lot of value for us still.
Right on, thanks. Yeah, just a sort of follow-up question. I mean, is there in your experience, I mean, these dashboards probably do include a lot of metrics that may have been evaluated in the literature, either, poorly or dismissed or whatever, but they still could be useful. But the problem then, I guess, is, have you run into any problems where they've been overinterpreted by the staff, or do you have to talk people down sometimes when they point to one of these numbers? in practice, or is it all like, are people pretty good at interpreting, like, let's say a host of like 20 metrics, of which there's, this is a multivariate output, there's correlations between them, are people able to handle that sensibly in your experience?
Yeah, I think it's a great question. The easy answer in the Whitecaps environment is I think yes. I think the more nuanced answer would probably come from my time with the United States Olympic Paralympic Committee, where we had multiple sports where we were doing this workload monitoring with. So we had practitioners with USA bobsled, USA gymnastics, USA boxing, USA rugby, all of these different practitioners. So the discussions and the interpretation of the same set of metrics for the large part widely varied. And that's where you would see, in some instances, I think overinterpretation, in some cases an underinterpretation or almost devaluing of the data. It really depends on the person that you're working with, their understanding of what the measure can or cannot tell you. And in a professional environment, in a single team like the Whitecaps, I think that's easy to have those discussions because you're in performance department meetings, you work together side by side every day. So the people that develop and implement those can have those conversations. I don't think we have a huge issue there, but I think it definitely depends on the people that you're working with. So as a quantitative analytics community, I think you can't have the metric without the education. That needs to be that interplay there. And they go hand in hand for sure.
And is there education within the White? Like, I mean, have you run sessions with IST staff on how to properly do data and that sort of thing? Is how much knowledge translation is going back and forth within the organization?
I think that the benefit of pro sport and just being in that, well, let's say before COVID, where you were just in the office every day and it was usual or normal, is more of that education happens informally. So you have the dashboard, you have the data available, and a comment or a question turns into a brief whiteboard brainstorm session where we have some really good practitioners and really intelligent people on staff. Dr. Ben Spohr, as our performance strategy, brings a wealth of physiology experience as well as understanding of the data with different sporting environments. We have a physical prep staff like John Poley, who's been using this day in and day out. So often it's not like, here, we're going to have a session on the acute chronic workload ratio in different pieces. It's like, hey, we're in on the morning and JP says, look, I saw another paper by Franco dismissing this or saying we should do uncouple. Like, should we do that and why, or how do we do that? And it turns into a quick discussion brainstorm. We get the whiteboard out and we write it up. So the education, at least in our environment, is probably more informal than a formal session of like, here's the dashboard, here's how we can use it.
Right on, thanks. Shrey Grover, you had a question for Johann, please go ahead.
Oh, hi, Johan. I had a question regarding you had shown a graph basically talking about the frequency and the longevity of the different types of injuries in football. So I wanted to ask about if these are somehow position related in football, because I believe every position would have different workloads on the field. And like, for example, players like Grealish or Hazard, they get injured pretty often because of the kind of workload they have. So when these analyses are done, do you consider the playing position of the field as well as to translate to how many injuries does this player playing on this position gets experiences? Is that taken into account?
Yeah, so I think it's a really pertinent question and understanding just the sporting context and sporting environment well. So it's an important conceptual piece, and it does correspond. So there's some literature suggesting, it's pertinent to our example today, that for hamstring strains, like regular high-speed running exposure is helpful to prevent subsequent hamstring strain injury. So essentially, if you have a player that hasn't sprinted in a month, and then all of a sudden you throw them in and they play 90 minutes and they're playing on the wing, then they're more likely to get a hamstring strain injury than if they've been exposed to those sprints more regularly in training. In that case, we do understand, at least in our analysis, what the match demands are in different playing positions. So I think in that slide where I talked about player maker, better understand what the match demands are for the academy. When we look at match demands, we do that at a player and position specific level. So we know that the players that are in a fullback or a wing position are going to have more high speed distance, especially in those transition moments. We also know our center midfielders are going to have a higher total volume of running distance across the game. So what we want to make sure that we attain in training and how we prepare them will be position dependent.
Great. And I had one other question regarding this. When you take into account different factors that can influence injuries, is adaptation to climate an issue? Like, for example, like I live in a hot country like India, and if I move to a colder place, I would experience dehydration or uneasiness in running at that temperature. So, is climate an important factor when you consider injuries or uneasiness to adapt to the high intensity games?
I'd say it's an important consideration. I think more resources are probably devoted and thought around how can we optimize performance given the environmental constraints. There's probably something there to your question about whether it'll predispose to injury, but most of the literature and for our environments, or for example, if we're going to go play a summer mid-July game down in Houston, for example, we think how can we plan and implement hydration strategies? When should we travel? How should we travel? The same thing we would consider altitude, but usually we're not thinking how can we make sure players don't get hurt? It's how can we make sure that they're able to maintain a high level of performance in the match. In terms of the academic side of climate and altitude change, et cetera, on injury risk, I'm sad to say I don't know a ton of the literature in that space, so someone might be able to give a more nuanced answer. But that's how we encounter it, at least in the applied environment.
All right, thank you. That's all I had to ask.
Okay, thanks very much, Shrey. So I don't see any other questions in the chat. So I think if someone wants to chime in with a question, I'll give you a few more seconds to do so. Otherwise, I'll shut down the recording and call a close to the meeting. Does anyone have any remaining questions? Please unmute. Okay, so I think then we're out of questions. So I'm going to stop the recording. First, I'm going to thank Johann again for a great talk, really insightful. Thanks very much for that. And yeah, we'll look forward to Dr. Schreier's talk coming up in a couple of weeks' time. And thank you all for attending.